Okay, so in this video we're going to talk about differentiability. We'll start with the definition. So where f prime of a exists, we say f is differentiable. And where it doesn't exist, we say f is not differentiable. So let's look at some examples of places where a function is not differentiable. So we'll draw three functions. Okay, so at these three locations indicated on the graph, the function is not differentiable. And the reason is, in the first one we have a discontinuity. So if we pick 2 points like this and draw a line through them and then move one of the points, the left point closer to A, then we'll get a vertical slope. But if we pick 2 points like this and then move the right point closer to A, then we'll get a different slope. And those don't match, and so it's not differentiable. The derivative is not defined. The left and right limits don't agree. It's also not defined at a corner for a similar reason. So if we pick a point on the left of A, we draw that secant line, and then we move that left point closer to A, we'll get a slope that looks like that. Pick a point on the right of A and then move it closer, we'll get a slope that looks like this. Those don't match, so the derivative is not defined. And here, if we pick a point to the right of A and we look at the limit of that secant line, we'll get an infinite slope, okay, or a vertical tangent. Infinite slope, and that is not a number. The limit doesn't go to a number; it goes to infinity, so it's not defined. Okay, a couple notes. Differentiability implies continuity, but the opposite is not true. Continuity does not imply differentiability, and you can see that in B and C, it's continuous, the function is continuous, but not differentiable. All right, let's look at another example. Okay, so in this example, we want to identify where the function f of x is not differentiable. But continuous. Okay, so here our function is going to start out like this. It's going to hop down like this. Okay, so let's first identify where f of x is not differentiable. So it's not differentiable and there's a discontinuity, so that's at 3. That's right, not differentiable. At 3 and 6. It's also not differentiable where there's a corner, so at 4. And it's not differentiable when there's a vertical asymptote, so that occurs at 1 and 2. Now let's identify where the function's not continuous. So it's not continuous at x equals 3 and 6. Okay, so the places where it's not differentiable but it is continuous are these points 4, 1, and 2. Not differentiable, but continuous here. All right, I hope you found this video on differentiability useful.